Good morning, engineers. It's Mr. Heller with this week's work again. Okay, so today we're going to be looking at two ideas of energy. We're going to be looking at gravitational potential energy and we're going to be looking at kinetic energy. These should be ideas that you're fairly familiar with from GCSE physics. I'll just write down a couple of formulas for us. Okay, so gravitational potential energy is equal to the mass of the object times g, the gravitational acceleration, which on Earth we're going to use as 9.81, just like we did in the SUVAC questions, times the height of the object that it's been raised by. Okay, you might also see this as being the weight of the object times the height, with just a little bit of a clue that mass times this gravitational acceleration is what's going to give us the weight of an object. Okay, kinetic energy, another formula that's given to us on the formula sheet, half times mass times velocity squared. Okay, and it's important that we get these units right. This is going to be kilograms, meters per second squared, and meters, and then kilograms there and meters per second, which we square. So that would come out as meters squared per second squared when we've squared the velocity. Okay, so let's have a look at the first question. The gravitational potential energy with an object of mass 20 grams at height 3 meters. So I'm just going to state my formula. GPE is mass times G times the height. Well, there's a bit of a trick in this question because this is 20 grams. So that's 0.02 kilograms times 9.81 times 3 meters. And when I work that out, that's actually 0.589 joules. Okay, 0.589 joules. Okay, so rounding that off to 3 significant figures, which if it wasn't, I would have already rounded off. Okay, so next one. Gravitational potential energy is mass times gravity times height. Well, I'm already given the weight, which is mass times gravity. So that's 7 times 4, or 28 joules. Watch out, because that one's a weight and this one's a mass. Okay, right, next question. Kinetic energy, half mv squared. Well, this is travelling at 72 kilometers per hour, so I might be tempted just to substitute that in. I'm going to convert this to meters per second before I start. So I'm going to say 72 kilometers per hour is actually 72,000 meters per hour. And that means that it's 1,200 meters per minute, or 20 meters per second. So that's the value that I'm going to substitute in for my velocity. And that's half times the mass, which is 10, times 20 squared. And when I calculate that, that's going to come out as 2,000 joules. And obviously I could write that as 2 kilojoules if I wanted to, but I'm going to leave it in terms of joules. Now in this one, I'm trying to work out the velocity when I'm given the kinetic energy. So I'm going to write my formula down again. Half mv squared. This time I know that this is 500 joules on this side. Half times 6 times v squared. A little bit of rearranging. Six recurring for v squared. And when I square root that, that's going to come out as 12.9 meters per second. I'll just put a little note there that I'm square rooting both sides of this. Okay, so there's some worked examples for you to do on the worksheet. There's an exam question for you to submit as usual, which is actually going to use this technique and a technique of adding together kinetic energy and gravitational potential energy. So good luck.